Okay, so now we're going to do a second example of this long division method. But before I do that, I want to draw your attention to the first example we did compared to this one. You'll notice this first example had 4 terms in it. They went from x cubed down to x squared, then x, then 2. You'll notice the second one only has 3, and it goes from x squared to x. What you should be aware of there is that they have skipped a term, and the term that they skipped is the x squared. X squared is missing. And if x squared is missing, then we have to be able to do this a different way. And I'm going to show you why first. I'm going to pretend, that's what the step number 3 is going to be. I'm going to pretend that I didn't recognize that the x squared was missing, because really we should check this before we do any long division problem, okay? But I'm going to pretend that I wasn't aware of it, and I'm going to start the process, and you're going to watch real fast what happens when I try to do the long division without the extra step I'm going to show you. Okay, so let's just pretend I was treating this just like the previous problem that I've done, okay? So in the previous problem, remember I'm doing this division, and I have to find the smallest number of terms that this goes into. Well, it's a binomial, okay? So I'm going to be going to the first 2 terms and trying to divide this into this. Watch what happens. Remember, we only look at the first. If I have an x and I want to get to x cubed, all I need is x squared. Well, the moment I put x squared up here, you should already be aware of a problem, because right below it is not an x squared term. It's an x term. So watch what happens when I try to multiply x squared with each of these. X squared times x is x cubed. That one's okay. Watch what happens next. X squared times negative 4 is negative 4x squared. We got a problem here. I can't subtract these because I can't subtract 2 terms that are not like terms. I can't do negative 13x minus negative 4x squared. Those are 2 different terms. So we've got a problem, and that problem is they skipped the x squared place. If the x squared is missing, we have to treat it almost like a placeholder, okay? So that's what we're going to fill in up here in step number 3. We're going to use placeholders if a polynomial degree is missing. So x squared is a degree of 2, and it's missing, okay? And you can have any terms missing. Like I could have been missing an x term or a constant term, okay? Well, the constant terms last, so it doesn't matter. But anything in the middle that you're missing, it's important that you use a placeholder. So just like whenever we're doing subtraction, and less specifically when we did like subtraction with decimals, like if I was supposed to subtract like something like this, you can't write that that's a 9, okay? We need a placeholder for that decimal place. And so what did we put in there when we made a decimal place? We put in a 0 as a placeholder. So what we're going to do now is we're going to put in a placeholder for the x squared term. So I'm going to rewrite this. When I write it out to do the division, I'm going to write it like this. I'm going to do x cubed plus 0x squared. I'm still marking the place. I'm just marking it with 0 because I really don't want to put a number in there, or else that would totally change the polynomial I began with. Minus 13x minus 12. So I keep right on with the rest of the terms after I plug in the plus 0x squared. Okay? Now I'm okay to do the division. So I'm going to make x go into x cubed. Remember, this is where we're stopping because it's a binomial into a binomial. So that's going to give me x squared. X squared times x is x cubed. X squared times negative 4x is negative 4x squared. Now I've got like terms. And don't forget, we talked about this, when you put in that minus, you're subtracting both. You have to distribute it. Well, x cubed minus x cubed would cancel. But what is 0 minus negative 4? Write it out if you have to. That's the same thing as 0 plus 4. So that's going to give me a remainder of 4x squared. So that's what I'm going to write there. I'm going to write 4x squared. So my next number to bring down is negative 13x, or my next term to bring down. And then I got to start all over. X into 4x squared. Well, I need a 4 there, okay? So, and it's going to be a positive 4. Oh, here, let me use the blue. I need a positive 4, and if I have an x and I need x squared, I need another x. And then I can do 4x times x, so that's 4x squared. 4x times negative 4 is negative 16x. Again, when I put in that minus, you might want to put parentheses to force yourself to distribute it, okay? 4x squared minus 4x squared cancels, but negative 13x minus negative 16 is really negative 13 plus 16. Those we both change to plus signs. That's a remainder of 3, and it's a positive 3. So I'm going to put 3x for my remainder. Okay. All right, then I'm going to bring down the last thing, which is a minus 12. Oops. And now I'm going to divide one last time, x into 3x. That's going to give me a plus 3 that I need. Whoops, let me make that blue. And 3 times x is 3x. 3 times negative 4 is negative 12. Look here. This time, 3x minus 3x is 0. Negative 12 minus negative 12 really means negative 12 plus 12. That's also 0. So I have a 0 remainder this time. So I don't have to write an r of any kind up here. So this right here is my solution to the division problem. But I'm asked to determine if the divisor, which is this, is really a factor. Well, the rule is if the remainder is 0, then it is a factor. So I'm going to write x minus 4 is a factor. And it happens to be a factor of this polynomial, or this if I don't want to keep the placeholder in there. So that's how you do long division, and that's how you determine whether or not something is a factor. Now, you could do all this work and get to a remainder, and it turns out that that's not going to help you, okay? That's not really a factor. We're going to be talking later in this chapter. We don't just randomly choose factors and try them all, because that takes a long time if we keep having to do long division problems, okay? What we're going to do is we're going to learn where to begin or some places to start. And then we're going to learn some other methods that are fairly quick and easy because there's a special pattern. But this general idea of long division could, if you found the right factor to try, it could give you the other factor, okay? And it could tell you if it factors or not. So then we'll take a look next at a new way of checking and finding a factor if we do what's called synthetic division, which I think is going to be confusing at first, but I think once you guys get the hang of it, you're going to prefer that much better over the long division method.